Now let's consider the region bounded by the graphs of these two equations and use my new cylindrical shell technique to compute the volume of the solid revolution generated by revolving that region about the line described by that equation. So the disco function align, we kind of got an idea what they look like, but I don't know how many points of intersection there are. So let me first do this. Let's find how many times those two curves intersect. I'm just applying my pre-calculus skill set to this question. Minus that number times this trinomial so it looks like the curves cross each other at x equals 2 and merely touch each other at x equals -1. But that's a line with a positive slope, so it must look like this. Oops. This is the region I'm revolving about that line. But that line y equals 15 is a horizontal line right here. Now, if I'm using the washer technique, my rectangle will be vertical. But since we're using the cylindrical shell technique, my rectangle is going to be horizontal and it'll wrap as such. That being the case, sorry for such a horrible cylindrical shell. My schematic. So look at that horizontal rectangle. It has a small dimension in the vertical direction. And so this delta y is going to turn to a dy when I set up my integral. Now, the radius of the cylindrical shell is nothing more than this y value minus this y value. And the height of the cylindrical shell is going to be this x value minus this x value. But this x value right here is described in that relationship. Sorry, you might make myself boring. Not changing anything. So the height of the cylindrical shell is this x value right here. Minus the x value on the line, described in terms of y as such. And of course, we're integrating respect to y. Oh, by the way, my bounds of integration, I forget what they are. Is that merely this extreme y value here to this extreme y value here. I don't know. Everything here is certainly in your command. We could finish this one up. I don't want to because most of the integration is easy. But I'm just nervous about one small thing. When you go ahead and expand everything and distribute this multiplication of the addition and subtraction operations, it looks to me like there's going to be an integral involving this times this. Do you mind if I just very quickly mention that? So y in cube root y minus 1. Forget about all the other coefficients out front. I don't care about that. I just want to make sure that you can evaluate this integral because this is something from your past. No bounds. Let's just talk about the anti-differentiation process. Now, when you look at this, I hope you're seeing that this multi-termed expression in the radicand's position is causing a problem. If it were a single-term expression, albeit paying the consequence that not a single-term expression, I think it'll make my life a lot easier. Let's force the issue. Sorry, my cat Pythagoras is squeaking. Another name for y. And another name for this. And of course, now it's a piece of cake to anti-differentiate term by term. Just use your power rule for anti-differentiation. I was just a little nervous when I saw that on the other side of the board. I want to make sure you do understand that you did learn how to evaluate such an integral last semester, first semester calculus, with your substitution technique.